Thank you very much, Alexander. So my name is Susanne Geissler. I work with the Austrian Sustainable Building Council, and I will present to you a few more examples regarding better quality of the works with the focus on compliance frameworks. I will present to you three types of examples, namely voluntary frameworks resulting in a label or an award, voluntary frameworks linked with financial support, and the third type are mandatory schemes. I will present one example for each type. For the first one, the Austrian Voluntary Green Building Assessment Scheme, called TQB, that's the abbreviation for Total Quality Building, and more information is available in QUALICHeCK fact sheet number 28. For the second type, I will present the German KfW quality assurance scheme. For more information, I would refer you to QUALICHeCK fact sheet number 44. And the examples for the two mandatory schemes are from France and from the Flemish region in Belgium. From France, it's the regulatory compliance checks of residential ventilation systems, with more information in QUALICHeCK fact sheet number 6. And the second example is about the quality framework for fan pressurization tests, with more information in QUALICHeCK fact sheet number 21. You will find the QUALICHeCK fact sheets under the respective section on the QUALICHeCK website. They are a collection of examples, or they represent a collection of examples. I think we have now more than 50 on the website, so please visit this section to read what we collected during the project. The first example is about the TQB, Green Building Assessment Scheme, which is a voluntary scheme applied in Austria. The scheme has two objectives: to ensure that the building was constructed according to the design, and to avoid mistakes during execution, during building implementation, and to ensure the quality of the works. In this scheme, also the first objective is quite important, because the assessment scheme also promotes integrated design. And in this case, design changes can be problematic because the design was optimized in a collaboration between architects and engineers. The scheme consists of several categories, several assessment categories. You see them here on the screen. There are 5. Energy is among them. Other categories are, for instance, health and comfort, resource efficiency, but also economy and location and facilities. Each category is subdivided into clear requirements which can be checked. On the right side, you see an example about the descriptions, what type of evidence must be provided. So everything is very transparent on the website. Evidence for checking can be calculation documents, but also measurements, which means also in this scheme, checking is done twice. Once in the design stage and once in the completion stage. At the bottom of the slide, you see the website with the link to the test tool. So it's also available in English and can be accessed through the website. I would like to show you one example how quality of the works is assured in this scheme. I present an example from the category health and comfort, and from the subcategory sound insulation. It is an example about ventilation systems. Ventilation systems with heat recovery are essential in highly energy efficient buildings. And from interviews with occupants, of residential buildings, we learned that noise of ventilation systems is often a serious problem because people switch their systems off, especially during the night when they feel disturbed by the noise of the ventilation. So this seems to be a quite frequent problem, although we don't have a systematic evaluation study on this. Switching off has, of course, an impact on indoor air quality, but also on the actual energy consumption because it disturbs the energy balance as it was calculated. So what is the reason for these inappropriate noise levels? They can be due to faulty designs, but of course also due to mistakes during construction, or both. In this case, the approach is to ensure good sound insulation in the planning stage by requesting for the design material and for the respective calculation. And after completion of the building, inspections and measurements are carried out and are requested as an evidence for the label to be awarded. So if all the requirements are met, the label is awarded. You see an example on this slide. It is an example of the building Johann Böhmstraße in Kapfenberg. It was a plus energy renovation. So in fact, the building generates more energy than it consumes. It was a best practice project carried out in the research program Building of Tomorrow, funded by the Austrian Federal Ministry of Transport, Innovation and Technology, called BBRI. The label is also supported by the Federal Ministry and by the National Climate Protection Program called QUALICHeCK. The second example I would like to present is the quality assurance system of the German Reconstruction Loan Corporation, Kreditanstalt für Wiederaufbau, KfW. In the scope of the funding program's energy efficient construction and refurbishment, loans and subsidies from federal funds are granted. And under this scheme, the eligibility for funding implies stricter energy requirements on new constructions and on buildings subject to refurbishment than specified in the regulations. And to check whether the objectives are met, whether the projects are compliant, the KfW has developed a comprehensive quality assurance concept, which is shown on the next slide. So you see that the quality assurance project comprises all phases of project, starting from project planning through application and commitment, through implementation until the project completion. There is a list of energy efficiency experts who are entitled to participate in the scheme, and there are, let's say, several quality assurance mechanisms applied. Very important is that there is a randomly carried out inspection of the energy calculation, so a random check during design, and a second random check later in the project at the completion stage. At the end of the project, there is an on-site inspection. So, what are the lessons learned, or what are the results of an evaluation carried out? I just come to the energy efficient refurbishments. Here you see that during the years 2013, 2014, 2015, around 100,000 funding commitments have been concluded. for a number of flats between 230,000 and 276,000. So that's quite a substantial number of energy efficient refurbishment carried out during the program. Regarding on-site inspections, about 430 on-site inspections per year are carried out, which corresponds to a sampling rate of about 0.3%. What are the insights gained during the period 2013 to 2015? In fact, the evaluation confirmed that the quality of planning and implementation is very high. Less than in 5% of cases, it was revealed that the requirements were not achieved, and a cancellation followed. In fact, this is a very important element of the compliance framework, that there are clear sanctions in case of non-compliance. And it seems that it's contributing clearly to a better quality of buildings. The next example is from France. It is not directly linked with the energy performance of buildings, but it's a good example for regulatory checks. In this case, regulatory compliance checks of residential ventilation systems have a long tradition, and about 5% of the annual production of new residential buildings are checked in France. How is this done in practical terms? About 70 full-time equivalent controllers are employed. However, this is for all checks in buildings and not just restricted to ventilation aspects. What are the results of the compliance checks on ventilation? The compliance checks reveal that 50% of the controlled buildings do not meet the requirements in terms of ventilation technical equipment. 43% of the controlled buildings do not comply with the regulatory airflow rates. And specifically, 84% of non-complying exhaust flows are insufficient, while 16% are excessive. And it's quite interesting that these results have been relatively stable over the years. So here you see some more detailed information about the deficiencies observed. I will not go into detail here. You can find more explanation on that in the fact sheet about this example. I would just like to come to the conclusions. In fact, the regulatory compliance checks performed on ventilation systems in new residences in France seem very useful to have a good picture of the status on the ground. But they seem to have little or no effect on the high non-compliance rate observed for many years. So, in fact, it is known that there are problems, but an improvement it has not taken place so far. And one of the reasons is that there is a lack of effective penalties. So this example shows very well that checking is an important element of compliance frameworks, but checking must be complemented by effective sanctions, but also measures to improve the quality of the works. And here I would like to refer to Hans' presentation he did before. So he was talking about qualification and qualification requirements, and also assurance schemes to achieve better qualification. So altogether are very important elements to improve building quality. In the case of France, another reason could also for, let's say, a little effects or little improvements could also be the absence of a link with the energy performance calculation. And this brings us to the last example of this presentation, which is the fan pressurization tests carried out in the Flemish region in Belgium. In this case, there is a link with the energy performance calculation, which could also, let's say, trigger improvements. So how is the situation in the Flemish region? Airtightness of the building's envelope is taken into account in the regional energy performance regulations. In case there is no test, then the calculation must be done with quite unfavorable default values. But if a pressurization test is done, the test results can be used as input data for energy performance calculations for new buildings like residential buildings, offices, and schools. This has quite an impact on the energy performance calculation result, namely up to 15% difference. Which means, of course, this is a motivation for people to do the air pressurization test because the EPC result will be better, or it will correspond better to the actual building performance. In fact, there was an increasing number of tests, and in this regard, quality assurance is very important to ensure correct test results, and in this regard, to contribute to the quality of the works, because, let's say, the situation is described as it actually is. How does this quality assurance look like, or how is it set up? So, in fact, there is a strong emphasis on the qualification of testers, so that they apply the method correctly, and there is a comprehensive control system regarding the test reports, but also regarding on-site controls during or after the measurement. The basis of all this is a dedicated web application which must be used. So, if a test is going to be performed, information about the test or about the measurements must be given at least 1 day in advance through the web application. The test reports must be uploaded, and also controls are organized at that stage. The result is then, if all the requirements are respected, a declaration of conformity generated by the web application, and this is needed as a proof for the measurements to be used as input data for the energy performance calculation. So these were a few examples about compliance frameworks. You find more information on these examples in the respective fact sheets. And of course, you find a lot of other examples in other fact sheets. You find them on the QUALICHeCK website. Thank you very much for your attention.